The problem we've got here is a vessel arriving at a harbour on a falling and ebb tide in the morning and has to go under a bridge. Charted height is given, 24 metres, and we're also given our draft and the overall height of the vessel from the keel to its mast top. Port authorities requiring a clearance of 0.5. And we're looking for the earliest time we can pass under the bridge. So what we need to calculate is the height of tide as it falls that will enable us to go under the bridge. And in problems like this you always need the highest astronomical tide of the port. Now it's Taku Harbour, and we've looked in the tables and we've seen it's the secondary port, standard port being Prince Rupert. So it's very important that when you get the HAT, you get the HAT, highest astronomical tide, for the secondary port, not the standard port. So we go into the tables and we see that Taku Harbour's HAT is 6.1 metres. So that's the value we're going to use to establish the height of tide. So I've done a sketch here, and you can see on the left hand side I've got the charted height of the bridge plus HAT means there's a maximum of 30.1 metres. Our vessel from keel to mast top is 32.6, draft 5.2, so the air draft, the difference between this and this, is 27.4, but we do need a clearance of 0.5 above the mast top, so the total height is 27.9. Available is 30.1, so it means that the maximum height of tide 2.2. So in other words, when the tide falls to a height of 2.2, we'll be able to actually sail under the bridge. So what we do now, we go in the tables for Prince Rupert, and we get the times: 0605 high water, 1140 low water. Apply the corrections, and these are the times of high and low water for the secondary port. And we get the time difference there for our plotting, 5 hours 35. Then go through the procedure for working out the values of low and high water that we need, remembering that the seasonal correction for the standard port, which is applied first, we always reverse the sign, and the seasonal correction for Taku Harbour of course remains the same sign. And if you're unsure about interpolation, I have done a separate video for that. So now we'll look at the tidal graph, and we've written time of high water there, low water, high water, 2.2, go across, do visual interpolation, come down, and we see it's 3 hours 30 minutes after the high water of 05:35. So the earliest time is going to be the 3 hours 30 correction plus the high water, gives us 0905 on the 20th of August. The second part says that we load cargo, and now we've got a draft of 6.6. We're now going to sail on the following flood tide, and what's the latest time? In other words, what height can the tide get to so that we can still get under the bridge? Our draft is now 6.6 and it was 5.2, so 1.4 metres deeper in the water, which means that in effect our air draft is reduced by that amount. So doing the calculation there, it shows that our height of tide now can actually be 3.6 rather than the 2.2, because the vessel's draft is deeper. So we get the following high water. Obviously we're using the low water, then the following high water, apply the corrections as usual, find now that our time difference is 6 hours 25, do the usual calculations, and we're now going to use 1.7 and 4.1 with the difference of 6.25. And of course on this time we're going to use the left hand side of the graph because we're going from low towards high water. And we interpolate visually again, we find the difference is 1 hour 50. So the latest time on the following flood tide will be the 1735 minus 1 hour 50, 15:45 hours on the 20th of August. So it's important that you get the calculation right for the height of tide, and it's important that you use the correct highest astronomical tide if it's a second report.